Hello everyone. Today my topic is corrosion. Without wasting your time, I'll simply dive into the topic. It is a topic in master's chemistry. So corrosion, it is defined as the deterioration of a material through an unwanted or you can say unintentional chemical or electrochemical reaction that occurs between the environment and the surface of the material. So, to in detail study about this corrosion, there were different kinds of theories given. So, let us see what are the different kinds of theories. That is, depending upon the attack of the metal, corrosion has two types. It may be dry corrosion, that is corrosion occurring due to some kind of chemicals. Or it may be wet corrosion. That is, you can say, electrochemical corrosion. Now let us see what are the different kinds of dry corrosion. Corrosion occurs mainly through the direct chemical action of atmospheric gases. There are three main types of chemical corrosions. The first one, corrosion due to oxygen. This corrosion due to oxygen is further divided into three types: stable oxide film, unstable oxide film, volatile oxide film. The second one is corrosion due to other gases. It may be protective film or may be due to non-protective film. The third type is corrosion by hydrogen. It is further of two distinct types: hydrogen embrittlement or hydrogen attack. Finally, liquid metal corrosion. So let us see in detail about corrosion due to oxygen, or you can say oxidation corrosion. It has been found that oxygen present in the medium directly attack the metal surface at low or high temperatures, usually in the absence of moisture, which can be given by this equation: metal plus oxygen gives metal oxide, where M stands for metal. Let us see the mechanism of oxidation. 2M goes to 2Mn plus 2Ne minus with the loss of electrons, and N by 2 number of oxygen plus 2Ne minus will release N number of oxygens with gain of electrons. So let us see the net reaction. That is 2M plus O2 will give us 2Mn plus NO minus. So let us go to the next one. Stable oxide film. Stable oxide film can be an impression in nature and can get adhered tightly to the metal surface. Using filling width rule. According to this rule, an oxide is protective or non-porous. It may be sometimes very clean. There is no porosity in it. If the volume of the oxide is at least as great as the volume of metal from which it is formed. Such oxide film form a barrier for further attack of oxygen. Next, let us see unstable oxide film. When the oxide film formed is unstable and it decomposes back into the metal and oxygen. That is 2MO, metal oxide, will give us metal plus oxygen, and this can be decomposed back into the metal and oxygen. Therefore, oxidation corrosion is not possible in cases of noble metals such as silver, gold and platinum. Let us see the next one. Volatile oxide film. When the oxide film formed is volatile, It vaporizes as soon as it is formed. Let us see the next one. Corrosion due to other gases. Extent of corrosive effect depends mainly on the chemical affinity between the metal and gas involved, and just as in case of oxidation by air, the degree of attack in such cases also depends on the formation of protective or non-protective films. Such examples of such metals are F2, chlorine, carbon dioxide, hydrogen sulfide, sulfur dioxide, etc. Now, if the film formed is protective, or you can say non-porous, like that of silver chloride, resulting from the attack of chlorine gas on metallic silver, the extent of attack decreases because the film of silver chloride formed protects the metal from further attack. Let's see the next one. If the film is non-protective or porous, the surface of whole metal is gradually destroyed completely. Example, dry chlorine gas attacks on tin, forming volatile film of stannic chloride, which vaporizes soon from the tin surface, thereby leaving fresh metal surface for further attack, which is highly dangerous. That is, a lot of corrosion keeps on taking place, and holding back the corrosion is very, very difficult, and it is also highly uneconomical. It is not so cost effective. Corrosion by hydrogen. Action of hydrogen on metal occurs by two distinct processes. The first one, hydrogen embrittlement. Now here, gases like hydrogen attack metal. This is known as hydrogen embrittlement. Now, it is due to the formation of nascent atomic hydrogen as a result of chemical or electrolytic action occurring at metal surfaces. Let us see this with an example. Fe reacts with hydrogen sulfide to give FeS plus 2 atoms of hydrogen. That is, atomic hydrogen is formed. This evolved atomic hydrogen diffuses readily into the metal and collects there in voids. H plus H, that is, it recombines to form molecular hydrogen. This molecular hydrogen is trapped in voids. While the process of formation of atomic hydrogen, that is diffusion into the metal, collection in metal voids and formation of molecular hydrogen continues, causing accumulation of molecular hydrogen inside the metal. Due to this, metal becomes weak. That is, we call it hydrogen embrittlement. Hydrogen attack. At high temperatures, hydrogen attack is also due to diffusion of atomic hydrogen into metal. But atomic hydrogen is formed by the thermal dissociation of molecular hydrogen. That is, H2 gives H plus H. That is, thermal dissociation takes place. This atomic hydrogen is chemically very active at high temperatures and readily combines with carbon, sulfur, oxygen or nitrogen, usually present in small amounts in metals. Last one, liquid metal corrosion. This is due to the chemical action of flowing liquid metal on solid metal or alloy at high temperatures. Such type of corrosion has been found to occur in devices used for nuclear power. The corrosion reaction involves either dissolution of solid metal by a liquid metal or by internal penetration of the liquid metal into the solid metal. Both these modes of corrosion cause weakening of the solid metal.